So, we're looking at now angles with trig. Right. Before we get into the actual triangles and some other things that have to do with different things, we're going to have to talk about some vocab and some basic ideas that's going to happen. Okay? So the first thing we have to talk about is angles can be anywhere. So we kind of standardize them. We talk about angles in standard position. And think of it putting on the axis. We have an axis here. Well, what happens is we are literally starting right on this part, going into the first and fourth quadrants there, going to the right. I always like to start on that positive x-axis. Think of it that way. We're going to call this the initial side. Then we start rotating. All right. Rotations can be counterclockwise or clockwise. We as mathematicians always go counterclockwise. Okay? So if I go counterclockwise, I'm going to rotate up. Where I end is called the terminal side. Right. Standardizing it means that the terminal side is going to be able to tell us something, where is it located, quadrants, things like that, because we're always the same. Right? An angle in standard position is where the vertex is the origin, and its initial side is that x-axis, and then up here is our terminal side. Okay. An angle for us now, we are going to use the Greek letter theta. Theta. All right. So, just a reminder, positive angles are generated by going counterclockwise, while negative angles are going to be going clockwise. Think of how you remember the quadrants, 1, 2, 3, 4. Those went counterclockwise, 1, 2, 3, 4. We're going to need those quadrants later. All right. So we have a positive 30-degree angle over here and a negative 30-degree angle that direction. Okay. The next thing we're going to realize is coterminal angles. There are two different angles, but they start with the same initial and same terminating side. Usually they're in opposite rotation, but this is not always true. Alrighty? The sum of the absolute value of two coterminal angles equals 360 if it is less than one rotation, aka it's between negative 360 and 360. That's what they're saying. They always make a full circle. Alright? So as you can see, this angle here is the same as this angle here. Similarly, this angle here going counterclockwise is the same as this one clockwise. So, big thing to realize, we are going to be talking about the four quadrants, 1, 2, 3, and 4. And we can tell where an angle finishes, and we can name it by quadrant then. The idea is, oh, this angle is quadrant 1, quadrant 2, quadrant 3, quadrant 4, just by the way it looks. So, right here you can see this is a quadrant 1 angle. A quadrant 2 angle goes from here to here. Quadrant 3 is all the way there. And quadrant 4 is all the way there. 330 degrees being in quadrant 4. So, the other half of this is if we go negative. Negative 50 degrees is in quadrant 4. Negative 115 is in quadrant 3. Starting here at that x-axis, it's quadrant 2 and quadrant 1. So if you look, this negative 300 shares the same terminal and initial size as a 60-degree angle. We're going to go that way. We're going to see that a lot of angles are going to repeat themselves. Right? But again, another thing is name that quadrant is going to be a game to us that we need to know, because that's going to determine some of the ideas with sine, cosine, tangent, and reference triangles later on. So, naming the quadrant is big. Now, the big thing to realize is each quadrant is divided by 90 degrees. So this is, as you know, the first quadrant is 0 to 90. Quadrant 2 is 90 to 180. Quadrant 3 is 180 to 70. And quadrant 4 is 270 to 360. Okay. Now, we are going to talk about the specialty angles. Okay. Those are called quadrantal angles. Those are the ones that lie right on the axis. 90, 180, 270, 360, negative 90. Now, you can see we can't name the quadrant because they're in two. So later on we're going to realize, oh, those are specialty angles as well, and we're going to have to do a little bit more work whenever I see one of those. Now, the other next thing is we're going to talk about angles of more than one rotation. right? You can turn more than 360 degrees in your life. Think about it. 720, 180. All I can think of is snowboarding moves. It's noticing this. If you go 360 degrees, didn't you get back to where you started? Well, theoretically, you're coterminal to an angle that's 0. Right? So just take a look at this one right here. If we have an angle in standard position starting at 0, so we start here, you go 90, 180, 270, 360, we still have some angles measurement to go. We have another 40 degrees. So this angle is right here is 400 degrees. But if you noticed, it's also coterminal to 40 degrees. They look the same. All right? 510, and by the way, a 400 degree angle is in quadrant 1. Same as that. Now if we look at 510, if we started right here, because again we're going to start in standard position, 90, 180, 270, 360, 450, we still have about 60 degrees to go. So notice how we're in quadrant 2 this angle is. And if you thought about it, we've gone 450, there's still another 60 degrees here. This is 90. This is the same as 150 degrees. Okay. Negative 450, that means you start here, but now you're going the opposite direction. Negative 90, negative 80, negative 270, negative 360, negative 450. So we have this angle, and you should be able to tell, like, ooh, look. Oh, first of all, it's quadrantal, so I can't name the quadrant. But it's the same as negative 90. But also you should notice that it's the same as, if I went this direction, it's 270 degrees. 270, negative 90, negative 450. There might be something going on there, but we'll take a look at that. We'll talk later about reference angles. A reference angle is a positive acute angle that's between the terminal side and the nearest x-axis. We're going to use these a lot later. The idea is, here you can't determine it. But here you're like, this is the actual, right here, the reference angle. Here is the reference angle. So we're going to have to determine that, but that's for later on. We'll do that later. Now, here's the cool thing. You can find any angles, if you notice, between these two. Look. Oh, look, 440. They're off by 360. Here, if you took away 360, you get 150. From 450, if you added 360, you get negative 90. But if you add another 360, you get 270. So what we're going to realize is every rotation is going to lead us to another coterminal angle. If you're off by 360, you can get it. So you can find any type of coterminal angles. There are technically infinite many, because you can add 360 or subtract 360 as much as you want. Later on we're going to see the most useful is anything between 0 and 360, because those are the ones we're going with. Okay? So if we want to find a coterminal angle, all we're going to have to do here is literally add or subtract 360, whichever we wanted to. So if I wanted something coterminal to 120, all I would do is add 360 to it, and you can add 360 and you get 480. Alright? You could also subtract 360, and if you subtract 360, you get negative 240. Both of these angles are different numerically, but look the same as 120. If I wanted to find here, we'll just subtract 360. We'll see that we get negative 60. But if I wanted to add 360, you can see that I can get 300 plus 360 is just 660. All right. 460, if we subtract 360, we're going to notice that, first of all, it's greater than one rotation. Think about it, greater than 360. So 460 minus 360, and you get a hundo. If you wanted to add 360 to it, you're going to get 820 degrees. Right here you can see we have more than two rotations, actually, because 720 is going to be 360 plus 360. So if you subtract 360, 790 minus 360, you're going to get 430. That is coterminal angle. But later on we're going to be like, nope, I don't want it. It's bigger than 360. So you could actually subtract 360 again. And notice that it's the same as 7. All of these angles look the same as this one, but have different numerics. Okay, just like before, if you take negative angles, you can add 360 to it. Like here, another coterminal angle is 290. Negative 200 if you add 360 to that. you're going to get 160. Negative 390, you can add 360 to that, you get negative 30. But then if you wanted to, you can get that positive by adding another 360. By the way, that's 330. And over here, if you add negative 900 plus 360, you'll get negative 540. Okay. And then if you add 360 again, you're going to get negative 180. If you add 360 again, you get 180. Okay. So later on, our goal is going to be to name the quadrants of these. Right. Over here, this is going to be quadrant 4, because right here, the negative 70, because it's 290, and it's between greater than 270. 160 is between 90 and 180, which is quadrant 2. This one is quadrant 4, because if you add 360, it's 330. And 180 doesn't get a number because, well, it's quadrantal. Right. The last idea is, again, keeping it between 0 and 360. So all we got to do is subtract or add, doesn't matter, but our goal is to get between 0 and 360. So 500, I think we're going to subtract 360, and you can see that's 140 degrees. So that 500 degrees is the same as 140. We're in quadrant 2. Negative 375, if we add 360, we're still negative. It's negative 15, but if we add another 360 to it, we're going to get to 345. And that's in quadrant 4. And 580, if we subtract 360 from it, you're going to get 220. My 2's don't like to come out on this for some reason. And 580 minus 220, or 580 minus 360 is 220. That, by the way, is quadrant 3. So you can see we're just making angles, and our goal is to get them as simple as possible here. And see where they end up. You can see there's lots of practice. We get bored. But as you can see, this is our little thing with angle. I'll talk to you later. I'll see you in class.